Although we do not have the opportunity to have your queries answered during the event, we would wish to do so later and put it up on our event page. In case the speakers wish to answer your queries also, we would like to take them up after this event. Uh, I would like to take you through the first flow of this event at the beginning. So going through the agenda, we have a few changes here. Yes. Instead of Dr. Winfred due to his unavailability today, Mr. Tobias Winter will be joining us. And to launch the report from NITI Aayog, Mr. Shudhendu Sinha sir has an important official commitment due to which he could not make it in the last moment. But we are happy to have with us Mr. Vijay Kumar sir, Joint Advisor, who will be delivering the keynote address and launching the report. As the guest address, we have from Mr. A.K. Rajput, Chief Engineer of CEA. Later, we have a presentation on Report-3 from Professor Zakir, Department of Engineering and Science, IIT Bombay, followed by the closing remarks by Dr. Indradeep Mitra, Team Leader for E-Mobility, IGEN Program, NDC-TIA. So first and the foremost, I would like to invite our first speaker, Mr. Winter Tobias. Mr. Winter Tobias is the head of Indo-German Energy Forum Support Office, GIZ India. And over to you, Mr. Tobias.
Namaskar and welcome everyone. Thank you, Sahana, for the kind introduction. I was asked to just say a few words and make it brief. I mean, there is no doubt, no? Direct electrification is the way, be it in industry, but also be it in mobility. German government actually recently has even ruled out further support for hybrid cars. 26% of all passenger vehicles registered in the year 21 in Germany already came with a plug for charging, and 43% of all newly registered cars were either hybrid or entirely powered by batteries. So no doubt, e-mobility is on the rise everywhere in the world, in Europe, Germany, but also in India. I was told that especially in the 3 and the 2-wheeler market, you are actually leading the worldwide development in terms of deployment. So amazing to know. This has impact on the grid. And therefore, we are happy and delighted to know that on behalf of GIZ, partnering with NITI Aayog, we are today launching this third out of 4 reports, digging deeper into the topic of grid integration of of charging infrastructure into the grid. What is the good news? I think the good news is that destination charging at home actually does not need a fancy charging station, as we are often told, that charging with a regular plug at your home with 2,000 to 3,000 watt gives you around 100 kilometer overnight. I guess not everyone is driving a whole night, and I guess not everyone is driving more than 100 kilometers a day. So just by having a plug nearby, a regular socket, a regular plug, we are able to charge our electric vehicles with around 100 kilometers per day. And that also means that an electric vehicle in destination charging mode is nothing more than an air conditioner. And I think there is very few countries that add so many air conditioners per household as India. So if we just know that India is capable to add 5, 6 air conditioners per connection, then one more air conditioner or one more electric car actually doesn't change too much to the grid infrastructure on the household level. But there's also good and bad news on the fast charging side. Fast charging goes up. First deployments in Europe now with 350 kilowatt. 350 kilowatt. This is more than 150 AC split ACs switched on at once. So this is a lot of power, and there, yes, this is something which really needs to be looked in, and booster batteries are being considered. A lot of infrastructure may have to be upgraded to make this possible. So I'm really looking forward to see electric mobility being uplifted in India on the domestic side, which I guess won't be a big issue by just charging with a regular socket. But if we talk about fast charging infrastructure with 300 kilowatt and more, definitely some homework would need to be done, and therefore it's very, very interesting and good to know that GIZ digged into the topic and made a global survey on the impact of charging on the distribution grid. So I'm pretty much looking forward to the launch of this report. Thank you very much to Dr. Indradeep and his team. Thank you very much to NITI Aayog for partnering in this initiative. Looking forward to the launch of the report, and wish us all very, very much new and encouraging insights. Thank you very much.
Thank you very much, Mr. Winter-Tobias, for those amazing words. You have certainly set the tone for the evening. Moving on to the most awaited part of this event, I request Mr. M. Vijay Kumar, Joint Advisor, Infrastructure Connectivity NITI Aayog, to kindly deliver the keynote address and release the report, sir.
Good evening, madam. Thank you very much. It is really great pleasure to participate in the event, the book releasing event. You see, this is NDC-TIA on India component project. The book, one of the deliverables. This book is prepared by the lead by the IIT Bombay along with the other consortium members. You can notice that zero emission vehicles will be the future, and decarbonizing the transport is one of the very key ambition of the World Climate Change event. Part of this, the EV integration, under EV integration, we are supposed to release 4 books in the NDC-TIA project. This third book is the electric vehicle charging infrastructure, and this grid integration India is one of them. The book is clearly well prepared, and it contains about the standards and EV policies in the various states of the India, and grid integration status of some of the states in India, and various policies highlighted in this book. It will be served one of the good reference book for the EV manufacturers and EV interested people. This is one of the exercise under the NDC-TIA project to disseminate the EV vehicles charging infrastructure. We can release the book now, madam.
Thank you, sir. Thank you for those kind words and the introduction to the report. We will now be releasing the report, and we would like to extend our gratitude to Vijay Kumar sir for participating in this event. This is the third report from our study. It is basically focused on India. The report is titled Electric Vehicle Charging Infrastructure and its Grid Integration in India, Status Quo, Critical Analysis and Way Forward. This report is now available on our digital library on green mobility. The link to the report is here. It will also be pasted in the chat box. This report is a part of a series of 4 reports, and we already have released first 2 reports last year, and they are also available on the DLGM portal. We request all of you to kindly go through the reports, and any valuable suggestions and feedback are also welcome to improve our further reports. And the 4th report, hopefully Professor Zakir will be able to speak more on that. Tobias, would you like to say something? Sorry if I've interrupted.
No, fine. I'm just amazed what a wonderful work you're doing. So yeah, please keep on going. Thank you.
Thank you. Thank you very much, Tobias. I would like to request now our special guest for the evening to provide the guest address, Mr. A.K. Rajput, Chief Engineer R&D from CEA.
Namaskar everybody. It's my privilege that I am here, and I am amongst the dignitaries here, those who have done a remarkable work in the field of the e-mobility. Basically, from the electricity side and from the government side, I can certainly say that e-mobility is a high priority area for the government of India also, as is the priority area for other governments. We are committed to the Paris Agenda. Our INDC commitments have already been met. So this way we are starting our journey towards the energy transition, and we are relying more and more wherever the opportunity arises on the renewable sources of energy. The basic aim of e-mobility launch in India is to reduce the emission locally being created by the internal combustion engines. So in place of ICE, we are relying on and we will be switching over gradually to the electric vehicles wherever the feasibility exists. Why I am saying the feasibility, that it is because it is related to the electric vehicle charging facility. And as has been told in the beginning also by in this forum itself and in other forums also, that domestic charging is permitted and the rates are also domestic consumption rates. So that is a big advantage and the flexibility. The consumers can charge their vehicles in the night or when the vehicle is not moving, say on Saturdays and Sundays also, maybe even during daytime. And for the establishment of EV charging infrastructure, what the government has done, several measures have been taken. And recently, in the beginning of the year, precisely the 14th of January, the new guidelines and standards for electric vehicle charging infrastructure have been launched. They also contain a business sharing model for the landowners, how the landowners can earn as the vehicles and the population of the vehicles keep on increasing because of the charging. So that will promote the establishment of the electric vehicle charging infrastructure. Certain other avenues are also being thought, that like the malls, public places and the offices. These are the areas where the lot of vehicle comes. So this way we will be able to reduce our oil demand and whatsoever extra expenditure we are making on the oil imports. When the electric vehicles will be constructed, they will be manufactured. So there will be change of job, and the change of job will be smooth because there will be lesser demand of the ICE based engines and the vehicles. So new type of the job opportunities will arise in the form of the electric vehicles manufacturing and also electric vehicle charging infrastructure and the maintenance thereof. Electric vehicles are also in our plan to support the grid. That is, the grid balancing will also be possible. Because what we are planning to have our tariffs in such a way that during when the RE is high in a particular area, the vehicles are promoted to charge during that time. So electric vehicles batteries are also a type of the storage. In addition to that, as far as the grid is considered, there will be presence of the storage element at generation, transmission and distribution systems also. So, and in the long run, the vehicle to grid has been planned. We have made certain indications in our official documents also, but it will take some time. As regard to the number of the vehicles, we are certainly lagging behind the world, other countries of the world, which are rich in EV adoption. But certainly we are ahead in the public transport type of the vehicles. Say three-wheeler is a unique thing which is in India, then two-wheelers for personal use and four-wheelers for taxi and the individual use. So these cars, three-wheelers and two-wheelers, these are the type of the vehicles in the EV segment which are dominating. Buses and trucks will come later, but now there are talks of large-scale purchase of the electric buses also. in the bulk, so that the rates are economical. In addition to that, EV policies have been brought out by the different states, and each and every state, specific to its requirement, has offered certain provisions, certain incentives as regard to EVCI and as regard to owning of the vehicles also. In addition to that, DHI has brought out the FAME scheme, and there are certain incentives on the e-mobility aspects from the Department of Heavy Industry side also. Fleet and depot charging will be the special type of the locations. So charging and depot charging, they are coming up. From the government side, we are ready and we are providing the policy and regulatory support. Recently, Planning Commission has also brought out the battery swapping draft policy. Maybe it is under consultation and may be finalized in due course of time. But what we have to say that in our federal structure, we have the power is in the concurrent stage, in the concurrent list. So state as well as the central have a role, and in the local distribution there is a more role and the more leading role to be played by the states. They have to facilitate more the EV charging facilities and other things. So in this way, one size fit to all the states cannot be adopted. States are free to adopt and choose their own path for promoting the e-mobility. Overall, overarching guidelines, those are issued by the central. Certain studies also need to be done, and this particular report is part of those studies, and study very well focused how the policy and regulatory matters, how the policy and regulatory aspects can have an impact on the e-mobility. Report is based on the extensive data survey analysis and the review carried out by the eminent professors and the eminent experts. The report also carries out the gaps and the scopes for improvement in the existing systems. It identifies the gaps, that what are the gaps and in what way the gaps could be plugged, and the measures to implement certain remedial measures. So I am hopeful that the report will help the regulators, policymakers, DISCOMs, and other stakeholders. It will on the automobile or the EV manufacturers also. They will come to know that in which direction the policy and regulatory supports are indicating and what benefit they can get out of the existing policies. In a similar way, they can raise their voice on the appropriate forum for modifying some of the things or bringing out new policy measures. So this way, the report forms a basis for the decision support mechanism, which is very much important in the case of the EVCI and the analysis on the power distribution network. Naturally, as Mr. Winter told that there are 350 kilowatt size, that particular rating of the chargers also. So naturally, these are going to affect the distribution network, and network strengthening is must in such cases. So for that also, we are having a revamped distribution system scheme, which is a quite big scheme, huge scheme, having 3 lakh crores of investment to be done in the 4 years on different aspects. So in that particular scheme, a provision has been made that the upward network strengthening, for the upward network strengthening, the assistance could be taken in the form of a scheme from that particular scheme also for by the DISCOMs. So DISCOMs will not be burdened. They will be provided assistance for extending the electricity network right up to the EVCI point, electric vehicle charging infrastructure point. Another important thing will come. I'm just going to finish in 2-3 sentences. Please bear with me. The planning and operation of the grid requires that how it will be integrated, how a large number of EVCI will be integrated into the system. So naturally, we have to take help of the digitalization. The digital tools will help, that how our grid is behaving and how this impact will be done. There are certain tools in the form of the softwares also, network analysis software also, that for a particular scenario, what will be the impact on the existing network, so that strengthening measures, strengthening requirement could be worked out. For supporting the grid, TOD type of the metering, time of use type of the metering, that is one means to curtail the demand, to contain the demand within the limits. So that will also be adopted. Technologies and standards are being evolved through Bureau of Indian Standards. We are evolving various type of these standards, and we are always looking for the new technologies to be adopted, maybe with the help of the GIZ, IGF, and other such organizations, those who are helping us. So policies and regulation, existing and required, these are the continuously changing because the technology is new, the evolution is new, and this business model is new. So these will be continuously changing, and we will be requesting that the concrete suggestions be made at appropriate forum so that it reaches at the central level and better policies emerges. Report also highlights the key challenges and the recommendations. So I think I should not tell the recommendations now. Professor Zakir, in his own word, in his own style, will tell the challenges and the recommendations in more detail. And I wish this program a success. The report is nicely carried out. I congratulate the authors. I congratulate the organizations supporting the study. Thank you.
Thank you, sir. Thank you for your amazing words and kind encouragement for our study and the report as well. Now that the report is released, let us know more on the key findings from this report. I would like to invite Professor Zakir Hussain, Department of Energy Science and Engineering, IIT Bombay, to present the key findings from this report. He has been instrumental in leading this study for over a year now, and he's also been the key person in the release of the other two reports, and we look forward to his presentation. Over to you, Professor Zakir.
Thank you, Sahana, for your kind introduction. I will try to share my presentation. Can you confirm, Sahana, if you can see the presentation in the presentation mode?
Yes, sir, we can see it. Please go ahead.
Yes, sir, okay. It is nicely visible. It is clear.
Thank you. Thank you so much, Mr. Rajput. So a very good afternoon, good evening to all the participants who have joined this event. As the earlier speakers already introduced the background of the study, I'll try to take you through the broader areas, broader concepts, and broader analysis that we have carried out in this study as a part of this report 3 in the series of 4 reports that we have built 3, already released 3 now reports, and 4th is on the way. Of course, the report is voluminous report of 320 plus pages. So therefore, it will be difficult to capture the whole report, but I'll try to take you through some of the major findings and analysis that we have carried out in this study. So let me briefly try to put out the approach that we have used in doing this study and how we have arrived at this report. So it has been actually multi-dimensional approach that we have used to perform this study and analyze various aspects of charging infrastructure and it is grid integration and put that up in the form of the report, the findings of all that analysis. So it included this desktop research, in-house analysis that we carried out at IIT Bombay. But more importantly, in addition to our own analysis, we integrated that with the stakeholder consultation, which was very active part of this study, where we had a consultation, we had various consultations with different key stakeholders of this EV charging infrastructure ecosystem, and that whole multidimensional effort led to this final conclusion of this study that is covered under report 3. These are the broader topics that we have covered in this report. Stakeholder consultation, the stakeholders in Indian EV ecosystem, very important aspect, because it is very important to know what the different stakeholders in Indian EV ecosystem and what are their roles and responsibilities, how they are coordinating with each other in this entire EV ecosystem. Then we also covered EV policies and regulations, primarily those aspects that were focused on the charging infrastructure side. Of course, in general, we analyzed the EV policies, but with a added focus on the charging infrastructure and its grid integration side, where we had whole historical background of the policies at the state level, schemes at the central government level, and various experiences and journeys of the electrical vehicle policy regulation and regulations at different state and central level. We also covered status quo of EV charging infrastructure and its grid integration, again both at the state level as well as at the national level, where we covered different aspects of this charging infrastructure and integration with the distribution system. Grid integration is one of the core areas of this report of electric vehicles, where we try to analyze the impact of this EV charging infrastructure on the distribution system. We had also try to understand what are the possible countermeasures to address those impacts of EV integration that they bring in, along the obvious advantages that e-mobility has, but they also introduce the technical challenges and issues in the distribution system. We also ventured upon this slow charging, fast charging, its impacts both on the battery side, on the grid side, and other aspects of this slow and fast charging. What we also did in this report, in addition to all this analysis that you would see in the report, we analyzed different tenders in EV charging infrastructure that have come out in India. We critically analyzed them and tried to see where we, in our opinion, we felt where the limitations which could have actually have been improved further, and what could be the takeaway messages from the existing EV charging infrastructure tenders that have come at national or the state level, from the state side, and try to have some takeaways from the analysis of those EV charging infrastructure tenders. We also did economic analysis of EV charging infrastructure integration, because it's very important to understand the techno-economic side of these aspects. While technical aspects are very important and critical, which comes first, and then of course economic side of that. After establishing the technical feasibility, then economic side of that comes. So we have ventured into that techno-economic side as well. So following all this analysis of the EV charging infrastructure and grid integration aspects, we finally identified the gaps which we felt that are critical gaps in the EV charging infrastructure in Indian EV ecosystem, which in our opinion needs to be focused on for seamless adoption of EV charging infrastructure. So, as I mentioned, one of the aspects that we covered is the stakeholders in Indian EV ecosystem. So please take a note of this disclaimer here at the left bottom of the slide. So what this actually tries to do is not only listing, the report is not only listing the different stakeholders and their responsibilities in Indian EV ecosystem, but also it tries to establish the relationship between different stakeholders when it comes to different aspects, as you can see here. This on the left side of the table, for example, EV incentive policies, payment of EV charging at CPO level, provision of EV OEM services, EV public charging, and other range of aspects, characteristics, and how they link these different stakeholders. They have this relationship that links different stakeholders in this EV ecosystem. So that is of course in more detail provided in the report. So we also touched upon the charging infrastructure in charging standards in Indian EV ecosystem. As you can see, the history goes back to this 2013-15. These standards on communication side initially, and then of course, which was one of the critical development in the charging standard development in India in 2017. This ETD 15 was actually constituted, and this ETD 15 has already come up various standards in the charging infrastructure, and some of them are even also listed in the recently released MOP guidelines. So of course that there has been developments in the charging infrastructure standards, and there are various aspects yet to be addressed. Several other standards yet to be actually built, issued and addressed. Several standard related issues to be addressed, and this ETD 51 is quite active in that area. So however, there are, in addition to BIS standards, which is now actually taking the shape of the standard in the country, there have been this DHI has been also involved in this Bharat AC 001 and Bharat DC 001 aspects which were earlier being adopted. But based on our analysis, we based on the overall study, we feel that as the Indian EV ecosystem charging infrastructure is moving towards the BIS standards, these AC001, because of various technical reasons, and DC001, we foresee it's not going to be active down the line as we move forward for various technical reasons, and in detail they are mentioned in the report. If we look at the EV market statistics at the national level, we have, as you can see here, more than 10 lakh EVs in India, predominantly two-wheeler and three-wheelers, and you can see this growth of these vehicles sold annually in India here, and different state analysis in terms of numbers. As you can see, UP is having in terms of numbers higher number, but in terms of percentages, other states are leading. Delhi is one of the active states in EV adoption, and you can see here in terms of the total these BEVs, battery electric vehicles, three-wheeler share is around 66%, which is the significant share actually, and then followed by two-wheelers. Four-wheelers are coming up not much in terms of percentage as of today compared to two-wheeler and three-wheeler, but there is a growth in the four-wheeler also, and with the goals that have been set at the central or state level, four-wheelers are going to grow in the numbers, and according to the charging infrastructure requirement for four-wheelers in addition to two-wheelers will have to be will have to be adopted. So charging infrastructure in India, there have been the major focus on the charging infrastructure has come from FAME scheme, FAME 1 and FAME 2 schemes of central government of India. And you can see the allotment of different states with these chargers under FAME scheme. But of course, in addition to FAME scheme chargers that have been allotted to different states, private charging infrastructure is there. There are many private charging players, charging infrastructure players active in India, many of them doing pretty good in terms of the business and growth in their overall business structure. So a lot of electric vehicle charging infrastructure is also coming. And we foresee that this sector is growing day by day with the increase in demand of electric vehicles. There is going to be need for more and more charging infrastructure, and as a result, more and more business for charging infrastructure will be there as we go forward. We have analyzed the EV related schemes at the central level, and we have analyzed the EV related policies at the state level. All those states which have issued either draft policy or the final EV policy or documentous orders, drafts related to the EV policy. We have analyzed all those policies at the state level and as well as the central government level, the schemes, with main focus on the charging infrastructure and its aspects. So you can see here the journey of this policy and schemes, regulations as well in the Indian EV ecosystem, starting from 2010, and now we are in the extended phase of FAME 2 currently, and a lot of developments have happened in between, and we foresee many more development is happening in this policy and regulatory direction. This is a kind of summary sheet of the different state policies that we have analyzed. Of course, as I mentioned, details would be there in the report, and this slide captures that how many states have already issued the final draft policies, final policy EV policies, and then draft policies, and then those who are already in the process of building the draft policies. So majority of the states, as you can see, a significant number of states have already come up with the EV policies, either in the final state. Some states have even released new EV policies as well, and their development is happening in other states also related to these EV policy measures. We have in each state, we have analyzed it in detail. This is just an example. We have taken Delhi state here, but otherwise we have given a detailed analysis of each state in the report. So you can see, for example, in Delhi, if we directly go to this three-wheeler segment, we can see that BEV is around 29% of the total these three-wheeler segment, three-wheelers in Delhi. And we have the CNG also to in a significant proportion, and we are expecting that these three-wheelers, of course, will actually grow further. If you remember, in the one of the first slides I showed, three-wheelers have the highest share at the national level as well. So there it is very evident and very well known that two-wheeler and three-wheeler in terms of numbers will have much higher penetration than the four-wheelers as we move forward. But it's not only the number game. It is also equally important the battery size, the electricity that it will draw from the grid. For example, a four-wheeler model of we have available in India, as high as 45, 46, in that range kilowatt hour, will be equal to around 22 wheelers of 2 kilowatt hour battery. So we have to see the battery capacity and the energy as well as the power this four-wheeler will draw from the grid. So therefore, even though in terms of numbers, four-wheelers and let us say heavy-duty vehicles may be low compared to two-wheeler, three-wheeler, but from the impact analysis on the charging infrastructure and the grid and interaction with the grid, that's going to be relatively significant. So we also try to see what are the key highlights of the different state EV policies, what are the pros of these state EV policies, and what could have been improved further. This is primarily based on the policy documents. Here we are not talking of the implementation level. To some extent, we are touching on the implementation aspects as well. But this analysis that I'm displaying here, for example, for Delhi, is primarily on the policy documents. And we have for each state highlighted, what are the advantages or highlights or advanced directions that the EV policy document is giving, but at the same time we have tried to highlight what are the improvements, what is the room for improvement in those EV policies of different states. So this gives a kind of condensed summary of the different state EV policies. After having a detailed analysis of each state in the report, you can see that we have tried to see the different features of these EV policies and relate which state is having different these features addressed in their or taken care of in their policy documents. For example, you can see here in this case, Andhra, in terms of the policy document, is actually taking most of the features here compared to other states. So now that was the policy side. Coming to the EV regulations in India. If we look at the EV regulations, we have, because EVs or EV charging infrastructure is going to be predominantly connected at the distribution low voltage level, distribution and low voltage level. So therefore, CA will have a key role in the regulations when it comes to these particularly technical regulations, when it comes to, and other related aspects when it comes to connection of the charging infrastructure to the distribution system. MOP has come up with the charging infrastructure guidelines in 2018-19, and we have the recently issued one as a second revision in 2022, which has actually brought a lot of developments in this charging infrastructure, addressed many of the concerns, the issues that were raised earlier. But having said that, there is a lot of room for improvement and work on the regulation aspects when it comes to connection of the electric vehicle charging infrastructure. I'm just giving you here an example of one of the countries, that's Denmark, which has come with a separate grid code regulation in 2017 for this electric vehicle, charging battery connection, EV battery connection with the grid. And you can see how advanced the policy, regulation is here. There's a frequency, these are the capabilities that these different charging, charging infrastructure or the battery, electric vehicle battery that will be connected to the grid should have. If you look at this, we have different categories. A1, which is less than 11 kilowatt, charging point, and then B, C, and D, different categories depending on the power rating. They should have these different capabilities. For example, we can see frequency response capability. All these types of these chargers should have that, the capability. They may or may not be used, but they should actually demonstrate that capability. And other, power factor control, reactive power control, and other voltage control aspects, for example, for higher, power chargers. As our this opening remarks, our guest from GIZ mentioned a 350 kilowatt charger in Germany. I would also like to mention this infrastructure, this funding that has recently been rolled out in US, where the requirement of that, the EV charging infrastructure, the requirement is that each charging station should have a minimum of 4 chargers with a minimum capacity of 150 kilowatt. So that means minimum capacity of charging station should be 600 kilowatt. Now imagine that, higher power charging station connected to the grid. They need to accordingly have more, regulations in terms of how they are impacting the grid, how they are influencing the grid behavior, and how potentially they should actually help the grid if there is any issue with the grid. So therefore, for high power charging stations, there has to be accordingly higher, regulations that should that will actually discipline the overall, grid operation, which we have had a similar experience in renewable energy integration. Grid code regulations there as well have evolved over the years, and it is for us and in India opportunity to take an example of the grid code regulation evolution in renewable energy sector and try to look at our regulations from the charging infrastructure side and plan it in a better way. I think these are the highlights of this MOP charging, revised charging guidelines that have been issued recently in January 2022. I'll not go into much of the details of this, but some of the highlights you can see it has addressed, some of the issues definitely that were there earlier. Owners can change their EVs in their existing connection charge their EVs with the existing connection at their residence. Discoms can provide connection to PCS within 7 days. So it has, the guideline is actually more progressive in terms of how fast the Discom should provide the connection. In our, stakeholder discussions with some of the CPOs, we have come across of the cases where it takes a significant time to get the approval for the grid connection. So therefore, that is being disciplined through not only through these guidelines, but also at state level. State regulators, state discoms are actually, attempting to improve all these logistic related aspects of EV charging infrastructure connection approval. And there are other aspects also of this guidelines that in the interest of time we would not be able to discuss here, but they are detailed out in the report. You can see here we have analyzed the tariff also, the commercial side of this regulation is also commercial regulation of all these different states that have already in place these the EV special EV tariffs for EV charging load. So you can see that different states, and we have not only limited it to only EVs. We have also made a comparison with the residential and other commercial tariff that is already existing with the conventional loads, how they fare with respect to the conventional loads. So if you look at this, Goa has the lowest tariff compared to the other states, and Meghalaya has relatively the highest tariff, the EV tariff, and we foresee that there is going to be further development in this space. Okay, so there is this fast versus slow charging, a comparative analysis we have actually taken up in this study, where we try to analyze different aspects of fast versus slow charging. So there are impact on the battery health. It is quite often cited that fast charging can actually impact the battery or life of this electric vehicles. Our analysis has shown that's not necessarily true. It depends on various factors. It depends on which services you are offering from your battery. It depends on what are the environmental conditions, what is the ambient temperature when you are using this fast charging versus slow charging. So it's not a black and white where we can simply make a statement and conclude make one conclusion. For example, here you can see in this study, we have the slow charging 0.5 C, which would take 2 hours to charge. Then we have relatively fast charging, more fast and fastest here. Now look at the capacity loss of the battery. This analysis shows for the slow charging, if you see here, in this case, even slow charging has faster capacity loss than relatively higher fast charging. That's the reverse trend that we see in this particular case. Similarly, what the other thing that we have noticed from this analysis is ambient temperature influences actually much more the capacity loss of the battery than the slow and fast charging. You can see here, this is for 34 degrees Celsius ambient temperature. Look at the 46 degrees Celsius ambient temperature. The capacity loss is much steeper, faster. So therefore, more than fast charging, it is actually the ambient conditions that actually impacted the capacity loss of the battery. Technical impacts on the electrical grid. Of course, if we are having fast charging, it means the more higher capacity load, which means the grid has to accommodate that, and it should have that margin available, the distribution system. If not, then it may actually necessitate the grid upgradation. But then that should not be the reason to kind of shy away from the fast charging, because the loaders come on. We have industrial loaders, we have commercial loaders. They come onto the grid at different stages, and there is of course the upgradation part is very critical. Who is bearing the cost of upgradation? That aspect needs to be addressed. But fast charging, though it will have, of course, the impacts on the electrical grid, but it has also a potential to support the grid in many ways, which we have outlined it in the report. We have also tried to see this economic side of this fast versus slow charging. Depending on various factors, depending on how much utilization your charging station is having. There are cases, there are scenarios where for fast charging you may have more rate of return. You may have more profitability if you are having the fast charging. One of the simple reasons is that you will be able to serve more EVs if you are having fast charging station. So therefore, for example, this becomes very important, particularly in the public charging, which is dedicated only for charging the electric vehicles. I'm not talking here of the destination charging, let us say office public charging. I'm talking the dedicated public charging stations that are going to serve only these electric vehicle chargers, and they would like to charge as many vehicles as possible. And this trend is not only is not actually required from the public charging point, but also we can see from the trend that we have observed globally. In this slide, you can see different countries, EV countries, UK, USA, Norway, Sweden, Germany. We have analyzed a detailed trend of this. There has been a focus towards faster charging in public charging space, particularly. Of course, home charging is altogether a different side of it, but public charging is actually the public charging space is moving rapidly towards fast charging. Not only fast charging, now we have rapid and ultra rapid charging that is happening in different parts of the world. So we also try to see the cost side of it. This fast versus slow and the battery capacity later. If you see here on this left side of the plot, this is a normalized cost of the vehicle, and this is for 4-wheelers. This triangle is actually representing the vehicles with slow chargers, and the circle is representing the vehicles with fast charging options. So these, with the increase in battery capacity, of course, here you can see the increase in the cost, this normalized cost. But these vehicles, and we have made it anonymous in terms of the brand, and these are all in the Indian EV market, Indian market available. These are actually high-end vehicles, so their cost is going to be higher. But this section of the vehicles they have more or less closer similar features, and you can see the normalized cost of the vehicles with fast charging can even be lower than the slow charging, and that's available in Indian market. Now coming to the 2-wheeler segment, you see here again normalized cost with respect to the battery capacity. We can see here we have a similar trend. For 4 kWh battery, we have the lowest this normalized price, and the fast charging does already exist even in the market, in the Indian EV market. As you can see here, some of the OEMs are already having the 2-wheelers with fast charging option. So that was fast versus slow charging and different aspects of that. Impacts on the distribution network. In the interest of time, I'll not go into too many details, but these are the different impacts that this integration of EV charging infrastructure will impact, potentially influence the grid. Be it voltage issue, voltage profile issue, power quality issue, congestion issues, and other related aspects that are there. For example, we did this analysis on one of the distribution system in Delhi. You can see here, because of the electric vehicle integration in different feeders, this distribution system is experiencing low voltage. And you can see here voltage versus different buses. The voltage in some cases going even lower than 0.82, which is unacceptable. And we try to see now, okay, these electric vehicle chargers are creating this issue, are creating this voltage profile impact on the distributed system. So can we use this problem itself as a solution to the problem that they introduced into the grid? We try to analyze if these charging stations are, we took a case study where we try to take the reactive power support from the charging station, if they are capable of doing that. And you can see here the charging station itself actually were able to address the voltage issue in this distribution system. Therefore, we try to actually address the issues introduced by the electric vehicle charging infrastructure by the charging infrastructure itself. Of course, there are regulation and other aspects that need to be addressed. So another aspect on the cost or economic side of it, what we did is we took again a study in Delhi here. We're taking this food processing industrial unit, which has typically 0.6, 0.65 power factor. without any power factor upgradation, improvement. What we try to do is, if the charging station is available near this industrial load, how that can potentially help this this industrial load to improve its power factor and improve its earning revenue. You can see here in this table, without reactive power support, this is the per month demand charges, and these are the energy charges per month. But with reactive power support from this charging station, the per month demand charges reduce, and you can see that it actually results in the energy charge reduction as well. There are savings that you can see from this case study for this particular analysis, and there are reasonable and annual savings as well that this industrial load can potentially make by utilizing these charging stations for reactive power support. In some of the countries, these charging high power charging stations are mandated to support the reactive power on the grid side. So these are different ways that we can mitigate this integration impact aspects of the charging infrastructure. We can, of course, one possibility is upgradation of the grid distribution system, as was earlier mentioned by Mr. Rajput. Also, if there is high power chargers, there might be a need for grid upgradation, but not necessarily in all cases, even though it is a fast charging. If we try to adopt, let's say, coordinated charging, we try to adopt the smart charging, there is a possibility of not only reducing the need for this grid upgradation, but possibly in some cases even avoiding grid upgradation requirement. Then, yeah, of course, we have the sophisticated smart charging, advanced smart charging, and we have this passive price-based smart charging. We already have time of day tariff in place in some of the states, and this is one of the easy ways to adopt the smart charging without need for much of the communication aspects. So these are different characteristics or application of smart charging that these electric vehicles can actually participate in. So time-based EV tariff we see is actually can help at a very relatively with less financial or commercial implications can be actually adopted, and that can address a lot of other issues, be it congestion or other impact issues on the grid side. And then, of course, smart communication-based smart charging will have more flexibility in addressing these aspects. We have done analysis. What are the requirements for smart charging? For example, technical requirements are there, which are very critical. The infrastructure and other related aspects, protocols and other related infrastructure-related requirements. Regulation is very important, because without regulation, it cannot actually take up in the market. And the stakeholder role becomes very important in this aspect. So therefore, smart charging needs a coordinated effort, but it has a lot of potential to address a lot of issues that comes along with this integrated electric vehicle charging infrastructure. These electric vehicles not only will support the distribution system, they can also support the transmission system operator in different ways, which includes different ancillary services that they can participate in. The underlying storage in the EVs can actually help the grid in many ways if suitable regulations and the market is in place. As I mentioned earlier, we have analyzed several tenders on the EV charging infrastructure. While case-wise, specific tender-wise analysis is given in the report, but these are the broader general conclusions that we got. The main focus of these tenders have been primarily on this Bharat AC 001 and Bharat AC 001 chargers. Low power capacity of the chargers, in our opinion, will not be adequate for public charging stations moving forward, where we are, we have already come long way from 10, 15 kilowatt hour vehicle to 45, 46 kilowatt on average, for car in Indian market at the moment. Even though, at the global level, cars with the battery capacity of 135 kilowatt hour is also available. And this trend is going to, increase. The battery technology, as it advances, the energy density, the battery capacity of the batteries that come with the vehicle is going to increase. That's what OEMs have been doing. They have all along the history never gone back in terms of the capacity of the battery of their four-wheelers. They have only increased the capacity of the battery, and that's what we foresee is going to continue in the future years. And that necessitates this high power chargers as well. We have now, even in India, coming back, electric cars with 6 kilowatt charger, onboard charger, moving from 3.3 that we have been using predominantly. So then the compatibility issue comes with the all these old technology chargers. The compatibility issue, we have already, as you can see here, type 2 CCS. We're moving towards these charging standards, these protocols. So therefore, the compatibility issue will also come with the slow chargers. Let us say potentially AC001 or DC001. So to summarize some of the gaps that we have analyzed in the report and identified in the report, they are mentioned here. For example, on the regulatory side, we have what we feel is lack of adequate support for private sector players in charging infrastructure sector. Non-optimal allocation of PCS under FAME scheme. Our analysis shows that there could have been better or could be better alignment of the charging infrastructure allocation. For example, our analysis shows that Delhi in the Q1 of 21 under FAME scheme, FAME 1 and FAME 2, for 3,000 electric vehicles, there have been around 170 chargers allocated. While as at the same time, Chandigarh with around 100 these electric vehicles has been allocated with 120 chargers. So we feel there is a need for alignment of that charging infrastructure with the demand of the electric vehicles. Also, there are other aspects. For example, allocation of the land for these chargers in terms of through the FAME scheme. What we have observed based on our analysis and based on our stakeholder consultation, in many cases, what has happened is that this through FAME scheme, this charger allocation has been carried out through different PSUs or other state government agencies. And in many cases, what has happened is they have installed that in the space available with them, and those spaces are not necessarily closer to the market. So therefore, the electric vehicles, which could potentially use those public charging spaces, are not easily accessible in the market, in the city center, where they could be actually utilized more widely. So all those actually gaps we have analyzed, which we feel actually needs to be addressed on the regulatory side and the policy side. Charging infrastructure development, as you can see, we feel that public charging needs a reasonable focus on the fast charging. Slow chargers are unlikely to, because given our analysis and given the trend that is there across the world, for the public charging, again, particularly those public charging stations which are purely developed by the players, CPOs, for charging the electric vehicles, they would like to charge as many vehicles as possible with their charging infrastructure. Lack of standards, to some extent that's being addressed, but there is a lack of standard in two-wheeler, three-wheeler segment. That has any impact on how easily you can charge your two-wheeler across the country, as long as you are not having standard 15 ampere socket or plug with you. So from the public charging, you need to have the adapters for charging these two-wheelers. Interoperability is very important aspect that we feel need to be addressed in Indian charging EV ecosystem, and the building bylaws aspects also need to be taken into account. Distribution side integration of the EVs, we feel there is a range of actually improvements or steps need to be taken to accommodate this EV charging infrastructure adequately as we move forward in this journey of integration of electric vehicles. CPOs, we have identified some of the challenges with these pillars of charging infrastructure. in Indian EV ecosystem that we feel needs to be addressed. Smart charging, as I mentioned, it can potentially address a lot of issues. We need to work towards the smart charging, in our opinion. Challenges for V2X implementation, that needs to be also taken into account, because there are a lot of potential positive developments that can come out from these V2X services. RE-based charging, not one of the main motive behind moving towards electric mobility is carbon emission reduction. If we are not charging it from renewables, then our main purpose is, at least for short term, not actually fully addressed. Therefore, we should encourage renewable energy based charging, and various steps, measures, both policy, regulatory, and other measures need to be taken into that direction. Ancillary services, they can actually become an asset for the grid operator, not only in managing the grid, but also helping in increased penetration of renewables. Battery swapping. So this analysis for battery swapping, challenge in battery swapping, we have analyzed it, as of February 22. Of course, later on, the draft policy came from the NITI Aayog, and some of the aspects have been already, being addressed. But these challenges for battery swapping in India, we are talking about our analysis as of February 22. But this, for example, first one, GST is one of the issues that is still existing there. FAME 2 subsidies are based on battery size, so claiming subsidies for EVs without batteries would, there is ambiguity in that. There's an issue with that. Compatibility, batteries would need to be standardized, but of course there is an attempt through this draft policy to address at least this aspect to a reasonable extent. Need for understanding among different OEMs to have same battery specifications for, or at least some standards, mutually agreed standards for battery swapping. Ownership issue is there that we feel is still an issue, though draft policy is trying to address that in the EV, this swapping policy. Accountability issues, we still feel that OEMs will have to, there are other challenges. For example, based on our analysis, OEMs will not be very comfortable in giving the warranty of their vehicle when this battery is going to actually talk to their car, and therefore there needs to be addressing those issues, how these OEMs will actually still maintain that warranty part of their vehicle side when the battery from some other OEM is actually talking to its vehicle. So depending on that, how well that handshaking between these swappable batteries and the vehicle is happening, that needs to be also addressed. Communication infrastructure, we feel, needs to be taken up to adopt the smart charging and exploit the benefits of this electric vehicle charging infrastructure, electric vehicle batteries, that in many cases the battery in the vehicle remains unutilized for most of the day. So Sahana has initially mentioned it already about these reports we have in this study. Report 1, Report 2, both Report 1 and Report 2 are available on on different links, including NITI Aayog website. Report 3 will also, we have already given the links, and we'll have more links for Report 3 as well. But what I would like to mention is about the fourth and very important report that is coming out of this study. That is a detailed gap analysis and recommendations for seamless adoption of EV charging infrastructure and its integration with the distribution system, where we are analyzing in detail what are the key interventions that the Indian EV ecosystem, different key stakeholders need to actually take action on, which can help us in the direction of adopting this EV charging infrastructure and indirectly EV adoption in Indian EV ecosystem. There is a detailed analysis, research analysis, stakeholder consultation that we have done, cost benefit analysis that we have done under this report 4. It is at a very advanced stage, and we are hoping in next couple of months we should be ready with this report 4 launch as well. So with this, I would like to conclude the presentation. I'm sorry, I'm already, I have already short overshoot this the time that I was having for this presentation. So these are some of the conclusions that came out of this particular study that is documented in the report 3. Critical analysis of different policies and regulations. As you can see, we feel there is a need for more focus on policy and regulatory enablers for overall charging infrastructure in India. Need to address the issues for grid upgradation that I mentioned, because at the moment the grid upgradation is primarily given to be the responsibility of CPOs. So there needs to be, for example, RDSS, that scheme is there now, as I mentioned earlier by our speaker, that there can be potential, this can be to some extent addressed through that scheme as well. But there needs to be a sustainable financial model for accommodating this grid upgradation, particularly for fast charging. Land availability, to some extent it is being addressed, but there is a need for further improvement in this aspect. Battery swapping, the standard is to some extent again battery battery swapping policy is draft policy is addressing a lot of these concerns around the swappable batteries. Public charging stations, as I already mentioned, I am reiterating, particularly those charging stations that are dedicated for charging the electric vehicles. There is, in our opinion, it is inevitable that they will have to go for fast charging to charge more and more electric vehicles to have better and better financial model of their business, which we have seen happening across the world. Impact on distribution system, there is a need for well-planned adoption of this EV charging infrastructure for the distribution system operators. Smart charging, as I mentioned without taking further time, is also very important aspect that, in our opinion, needs to be focused on. So with this, I would like to conclude the presentation and hand it over back to Sahana. And again, sorry for taking a little more time than what I was supposed to take. Over to you, Sahana.
Thank you, Professor Zakir, for a very detailed presentation and also about the key findings from the report. I'm very happy that we were able to capture the essence of the report into your presentation. I take this opportunity to also thank the consortium partners. The consortium was led by IIT Bombay, along with Florence School of Regulation, Technical University of Denmark, Cardiff University, and Universidad Pontificia, Comillas. I can see a couple of hands going up. Like I already said, we do not have the time and opportunity to take up live questions. I would request the audience to kindly post your questions in the chat. We will certainly answer those questions and put up our circulate the replies on our social media handles and also on the event page. I would like to now invite Dr. Indradeep Mitra, Team Leader, E-Mobility, Indo-German Energy Program, Country Coordinator for NDC-TIA India Component, to kindly deliver the closing remarks.
Thank you, Sahana. Good evening, all. Very hearty welcome from GIZ India here. I hope I am audible here.
Yes, sir.
Okay, yeah. So I would like to first thank Professor Zakir, because it was very complex task to summarize the report. It's something like 300 pager, having 9 major and important chapters. Each are valuable and complex enough. And to summarize in 1 hour is not an easy task. And therefore, I would like to congratulate Professor Zakir first for that. And I understand and I hope that the audience will bear for the little bit overshoot of time of it. So first and foremost, I would like to express our sincere gratitude to NITI Aayog. They are our implementation partner for NDC-TIA project for India component, and particularly Mr. Sudhanjyoti Sinha, Mr. Vijay Kumar, and Mr. Siddharth Sinha. These 3 NITI Aayog officials are continuously encouraging us and closely coordinating our activities. There are plenty of activities, and not only from GIZ, but we do have 5 of our partners under NDC-TIA project as a whole consortium. I would like to thank our partners in this case also. For this particular project of this smart charging and grid integration of charging infrastructure and global review of charging study, this is a long study. It started last year and already 1 year back. We had also released the report. So the whole project, the encouragement also came from the high command, from the CEO of NITI Aayog last year also. And I would like to also express my thanks for that as well. On the other hand, for the specific work for this particular report, I would like to thank IIT Bombay, led by Professor Zakir, with the encouragement of his entire team, and also Professor Rangan Banerjee. He himself communicated and interacted many times in the beginning also. And I would like to also thank the GIZ team who was in charge of this particular study, and particularly to Sahana, you, continuous effort for this. Apart from that, the consortium partners of this particular study, namely Florence School of Regulation, DTU, Comillas, as well as Cardiff University, all of them were consulted and actively participated in brainstorming and opinion, and also report to international best practices and examples. So I'd like to thank all of them. This project is under the funding of International Climate Initiative of the Government of Germany, and this we'd like to thank for the getting the funds for this. Now, many organizations were contacted and consulted during the process of this report. So therefore, it's also very, very, I think, valuable that they gave us time and enrich us in our interview for this particular study. And for that also, I'd like to thank all of the organizations which got in touch with us for that. And we communicated, we reached out to them, and they were kind enough to accommodate us and involve in the brainstorming and express their opinions on that. A very large pool of organizations were contacted for the entire study. Apart from only this third report, the entire study consisting of 4 reports. And of course, like each time, I would like to thank the audience. It's quite late, and probably you might be thinking in the beginning, there are so many reports. What is new about it? But I am confidently can claim that if you really read the report, you can see a lot of valuable information inside, a lot of mixture of the analytical works, primary work is also involved. A lot of international references are given. So in one stop, you can understand and you can get the data pretty wide and pretty valuable. And I would expect that you would also keep in touch with us for our final recommendation report, which will come in few months. With that, I would like to thanks for all, and back to you, Sahana.
Thank you, sir. Thank you very much for those encouraging words, and also for thanking all our partners in the process. With this, we come to the end of this event. And on behalf of GIZ, IIT Bombay, and the entire NDC-TIA family, I take this opportunity to thank each one of you for taking your time out for this e-launch event. You may access the full report from the digital library on green mobility. The links are already pasted in the chat box, and also for all the participants and invitees, we will be circulating a post-event package which will have the link to the today's recording and also the presentation and the full report. In case any of you have any feedback or any queries regarding the report, please feel free to either contact us or IIT Bombay. Thank you all once again, and I wish you all a wonderful evening.
Thank you.